parts of the human body break down or are damaged, options are limited. Scientists are working on providing replacement parts on demand, like fingers, ears, and bladders. Laboratory-engineered bladders have already been successfully implanted in humans. The stuff of science fiction may soon be a reality. They begin with a mold, a finger mold on the right and an ear on the left. These molds can be made of synthetic polymers or natural materials such as collagen. Scientists will grow real cells on the molds. To obtain those cells, a scientist first extracts a small piece of cartilage, which is a type of connective tissue in the body. She chops it into little bits. She transfers the minced cartilage to a test tube, partially filled with a special enzyme. This enzyme dissolves tissue, leaving only the cartilage cells. She then places the test tube in a centrifuge for a high-speed spin. This causes the cartilage cells to separate from the enzyme solution and settle on the bottom. She siphons off the liquid and the tiny cells remain in the test tube. Next, she adds a red liquid. It's a culture medium. It will act as a fertilizer to stimulate cell growth. Transferred to a Petri dish, she swishes the mix to disperse the cells. Then it's into an incubator warmed to 37 degrees Celsius, body temperature. It's the perfect environment to spur more cell growth. Meanwhile, a computer-controlled machine builds the mold of the ear. It layers synthetic polymer to produce an authentic-looking shape. This process takes about 5 hours. In the meantime, the microscopic cells have multiplied 20 times. The scientist drips them onto the completed mold, where they continue to grow. In the future, cell-covered ear molds could be implanted under a patient's skin. Cartilage would form, and the body would accept the part as its own. Other scientists are working on growing blood vessels and heart valves. They start by extracting a type of stem cell from human blood. The researcher first fills a test tube with a clear, high-density solution. He adds diluted blood to the clear solution. Almost instantly, the different components of the blood begin to separate. The heavier red blood cells plummet, and the lighter stem cells rise to the top of the test tube. A spin in the centrifuge leaves the components visibly separated, allowing scientists to retrieve the desired cells. They'll convert them to endothelial cells, which line the inside of blood vessels and heart valves. In the meantime, they construct the blood vessel mold. The scientist adds solvent to liquid collagen, causing it to instantly dissolve. He adds little white beads. They're synthetic polymers. And they liquefy over a period of about an hour. They spray the collagen concoction onto a rod that spins as a carriage moves it to and fro for even coverage. The collagen and polymer mixture quickly solidifies around the rod. The scientist slides off the now hardened biomaterial. He has a mold for shaping a human blood vessel. He coats the mold with the microscopic endothelial cells, which by now have grown and multiplied. He then pumps fluid through it to simulate blood flow. This conditions the cells to go with the flow and collectively operate as a real blood vessel. To grow a heart valve, they don't actually build a mold. They use a real valve from a pig. The scientist plunges the pig valve into a container filled with a mild detergent. It goes into a machine that shakes it up. The agitation helps scrub off all the cells, leaving only the valve skeleton. He saturates the valve skeleton with human cells, where they grow and thrive. The research team then pumps fluid through the valve, just like they did with the blood vessel. This trains the cells to do the work they would need to do in the human body. Even Dr. Frankenstein would be impressed.